So let's talk about the role of the API gateway, right? What is the API gateway? How we can easily implement the API gateway, for example, in .NET Core, unless we need to or we want to use some other API gateway provider. And most importantly, what are the differences when we decide to send our request like synchronously via HTTP, or maybe we will decide to send our or process our request asynchronously by, for example, publishing these commands to the message broker.
Yeah. So basically the idea about the API gateway is that this will be nothing more but the sort of entry point to our application or maybe to our system in general. And the idea about the API gateway is that it hides the whole complexity of our system. So for the end user, the only, let's say, visible part of our system is the API gateway, some sort of contract that this exposes. And we as an end user don't care whether we have the microservices behind this or maybe the monolith or whether we call the external systems, right? So basically every operation goes through the API gateway, and it is its responsibility to actually, the responsibility to actually know what to do with the particular HTTP request.
Yeah, whether there is maybe some retry policy, whether maybe the API gateway, we talk to the service in different protocol, maybe in WebSockets, and we just send the HTTP request. Maybe there will be some authorization involved behind the scenes. So it's API gateway responsibility to, do all these things. We, as the consumers of the particular web API, ideally want to have like a single entrance to the overall system and treat it as a monolith. And we don't care that there is like 1 or 100 microservices behind this API gateway. So we'll talk about two possible approaches, like the synchronous and asynchronous. So with the synchronous approach, as you can see here, which is, I think, the most natural one, as the end user, we basically send a request. Let's say we made a request, create order, and it would be, for example, the HTTP post request. Then, given this synchronous nature, this request would be then forwarded further, for example, with its original payload, or maybe also we will, modify or transfer some headers on the gateway side. Then we will basically redirect this or forward this request to the particular service that is capable of handling this request, this command in that case.
Yeah.
For example, then our order service would return the response. It could be, for example, 201 with a location header. So the create status code, it would return this response back to the API gateway synchronously. And we as the end users would see, for example, this original status code with this header returned by this order service. And even though there might be some events involved during this order creation, it will be outside of the scope of the gateway. I mean, if there is an order created event, it might be published to the message broker, but the API gateway doesn't really care about this one, right? So this will be the synchronous approach. So maybe let's see it in action.
Yeah.
How we can run this synchronous API gateway approach.
Yeah, and this is worth mentioning that the synchronous version will be probably the most natural choice for the most of the operations.
And usually it makes the most sense because it's the simplest one. Either the request succeeds or it doesn't succeed, and we get the immediate response because everything will be done synchronously, right?
Yeah, so let's see this in action,
Yeah. So for the .NET developers, .NET Core developers, usually like the first choice, because we can use different gateways, like we can use Kong, Ambassador, Glue, TYK. There are like a lot of different gateway providers. Like most of them are commercial paid ones, so we have to pay for the gateways. Because when you think about it, it's like some sort of proxy with additional set of rules, additional mechanisms, middlewares, and some plugins. So there's like a lot of paid solutions that we can purchase. But for example, as a .NET Core developers, we could, for example, also use Ocelot, right? Which is a .NET Core library and will give us these gateway capabilities. I mean, even for the simple scenarios, we could probably create our own gateway.
Yeah, based on ASP.NET Core.
It's pretty much like read the request and just forward it to the particular service, like in a simple scenario, like some sort of reverse proxy mechanism. So let's say that we want to use the Ocelot gateway. And here are, of course, the documentation, how to run it. But now let's open the code. So we have this API gateway Ocelot sample within our solution. And within the SRC, we can find that, all right, so we are using this Ocelot gateway along with some other libraries. But if you were to use this gateway, if with this basic approach, what you would have to do based on this documentation is to simply invoke this add Ocelot, this extension to register all of these Ocelot interfaces and providers. Then within your application middleware, you would need to call use Ocelot, right? So you have this middleware, so it will take your request and process it by sending it to the particular service. And then you also need to load Ocelot settings, which usually live in a separate file. So here we have the default app settings with some logging, another sort of configuration, and here we have dedicated Ocelot settings. But we also extended them. We'll talk about this soon. So the default settings would be our base URL of the API. So for example, later on, when our API returns some location headers or some data that includes the original URI, that will be the URL of this gateway. And here's the important part. We have this reroutes. So basically, it's a set of rules how we can redirect our request to the particular services. So for example, here we are saying we want to have this template where whatever actually hits this our gateway / availability, everything like any sort of endpoint with query string, we would like to redirect this one to, in that case, to the localhost 5001. As you might remember, 5001 as a port for our availability service, right? So we will redirect everything that hits this availability service there as this template.
So basically, this looks like a simple registry.
Yeah.
But this is simply put in a JSON, right?
Exactly. So this is pretty much a set of rules defined in a JSON file. So let's see if we can make it work. For now, I will just remove these authentication options because we can also plug in easily, for example, into some sort of JWT middleware or other authentication provider. So I will just remove it so we will not have to perform the authentication. Also, nice feature, we have this quality of service options. So things like retry patterns, secret breakers, and so on. For example, using the poly, as you might notice here, we have this add poly integration. We do also have this built-in based on this configuration. So let's give it a try. Let's start our gateway. So we can open the Ocelot project. And again, let's just go into either run it via scripts or go to our Ocelot API. And then let's do .NET run. And also let's start our availability service.
Yeah, so now all the HTTP requests will be directed, will be called to the API gateway instead of the availability service direct, right?
Yeah, so from the end user's perspective, we will now only talk to the localhost 5000, right? And based on this set of rules, it will move this request to the particular services or microservices. All right, so let's try. Let's go into localhost 5000. So here is our hello message. And now we could try to do something like /availability and, for example, /resources. And here we have our resources list, right? So we just hit the following configuration that we have defined here. So whatever goes to availability /everything or any whatever, however we call this template, we will just redirect this endpoint with query string to this particular service that lives on this localhost 5001. So that's like the simple case, okay? And this is like a typical synchronous approach. And of course, somewhere here, we would also need to consider load balancing just to make sure that if we have like multiple instances of the services, that we do not, redirect the traffic to only the first instance of the service, right?
Yeah,
so
we'll get
some
to
load balancing things that should be also considered here, right, on this level.
Yeah, we'll get to this later in this module, yeah.
All right, but let's think about another approach. Let's say that we have, as you can see here, so we have our availability API, the internal API, but, and as you might remember, we have this, of course, web API endpoints, which will work synchronously, but we also have the asynchronous messages. So previously, we declared that we would like to be able to subscribe to this add resource or reserve resource commands, right? So we could potentially be able to receive this message coming from the message broker and process them asynchronously.
Yeah, and actually this makes sense in a couple of scenarios, especially if you have the command that will be processed for a long time, right? So maybe calculate statistics or process the video or something. So this potentially could take a while, and we don't want to hang up the connection between the end user and our distributed system. So, that would be the typical scenario in which we call the API and we see this with this loader, and we're waiting for the processing to be finished. Right. So what we could do instead, we could do this asynchronously and return the response immediately to the end user, and eventually try to communicate with him saying that, okay, your operation has just succeeded, right?
Right. So let's try to actually invoke the HTTP post method on our gateway, and let's see if it will be sent asynchronously or not, and let's see how we can actually achieve this. For example, RabbitMQ or any other message broker integration when we choose to use Ocelot, or when we choose to use maybe some custom code that we will write as our own API gateway when we use .NET Core.
Right.
So again, we can open the VS Code, and we can either open our API gateway, this one or this one, and we can try to follow this REST scenario. So we can open, for example, this Paco Ocelot REST, or we can just go to our internal availability REST and just change this endpoint from 5001 to 5000, right? So whatever we pick. So maybe let's open the Paco Ocelot REST, and here we will have this post operation. So we have this post availability /resources. Let's just ensure that you have the valid resource ID as this value. So let's make it maybe 20, right? Just so we have something unique. And let's try to invoke this post. All right, so we didn't get an error, which is nice. We got some 202 accepted message, whatever that means for now. But let's take a look at the logs maybe. So as you can see, we have actually received this message. So on our API, on our availability service level, we have received this message. So we got this log, received a message with this ID, timestamp, and so on with routing key, add resource, and we process this message here with this question ID. And basically, if you look into the database, we should be able to see that we do have this message. All right, so the data is here. It's been processed. Maybe right now, let's try to do it one more time, like with the same ID. Yeah. Let's say we are getting, again, we don't see any error, although we sent the operation to other resource with the same ID. So let's see on the error level, on the service level, here we can see some failures, right? So we have this failure log level. And as you can see, we have an issue when we try to process this message with this ID. And well, we publish this rejected event. So right now, as you might remember, we had this exception to response mapper defined within
message
our
mapper, actually. Message.
Yeah, exception to message mapper defined here, and we said exception to message, this one. And we said that when we receive, for example, an exception within one of our handlers of the particular type, then we want to publish this rejected event, right? So right now, that's what happened. We received the asynchronous command, we tried to process it, then we somehow violated this application logic because the resource with this ID has been already added previously, and it resulted in publishing this rejected event. But from the end user perspective, we didn't see an error. We just got something like 202 accepted. So I received your message, but I don't know what actually happened, right?
Yeah, this actually makes sense because the operation itself is asynchronous.
Right.
So the API gateway, its responsibility was simply to take the message, put some additional metadata, and publish this using some message broker. So basically, from the publisher perspective, this is simply, I put this on the exchange, my job is done. I'm not aware about the receivers. So actually, I'm not quite sure whether this operation, the message will be processed or not. The only thing I can guarantee is that that I put it there, right? So this is why we get the accepted.
The job is done for the gateway, right?
Yeah, the message has been accepted by the API gateway, but this necessarily have to imply the operation that is finished successfully.
Yeah, exactly. So before we dig into dealing with these asynchronous messages, let's just check how we can actually make this integration, for example, on the Ocelot level or any other .NET Core custom code that we might write for the gateway. So, for example, here in the Ocelot, what we have here under this infrastructure directory, we have like quite a few classes. And if you open these app settings for the Ocelot, which is the Ocelot.json file, you can see that down below we have this two like custom sections. The first one, the anonymous route, is simply for defining the set of potential endpoints that even though if they would be marked here as requiring authentication, like for example, we have the identity service somewhere here behind our gateway, and by default, it will require us to pass the access token, some way of authenticating the user to access any of its endpoint. But for example, if you want to do sign in, we probably shouldn't, require the token from when we make a call. So we can set some, anonymous routes here. But the important part, speaking about RabbitMQ, is this one, this so-called async routes. So basically, we are saying here, all right, so maybe I would like to have for the post method, and when I hit this route, so if I wouldn't have this one, if I were to remove this, and I would make the same post operation again, this would hit the internal API. So actually, this one, right? It would forward this request to this one, the internal API, for the HTTP request. But if I have this one defined here, then instead, when I invoke this endpoint, it will send this my actual payload of my HTTP request body to the message broker, and it will send this message to this exchange that I defined here using this routing key. And the way that it actually works, for example, with Ocelot, is that, so down below here, we are saying, all right, so there I want to use the default Ocelot middleware, which will forward my request. But before I make this middleware, before I run this middleware, maybe I would like to see if I shouldn't put this message into the queue. So here we defined like a custom middleware that we just called asynchronous middleware. And what's happening here is that we might have, for example, our RabbitMQ client. We might have some additional values. And if there is a match, so if there is a match between my request method and the path, meaning that if, for example, I'm sending the post to this endpoint, I will see that there is a match. And if I have a match, then of course I can check some authentication options and so on. But eventually I will produce a message. So I will get my payload, from my incoming HTTP request. I will, for example, build this message just using the default JSON initializer. I will read this payload. I will transform it into some message, and then I will just send this message to my message broker, for example, using RabbitMQ client or in the library.
So simply check whether I have my route defined to eventually use the RabbitMQ instead. And if so, simply I want to publish this one. I will not invoke the actual HTTP the endpoint defined by the particular microservice. So
that's pretty much it. And whether you choose to use Ocelot or anything else, it's usually not a problem to write your custom integrations. Just you need to keep in mind that usually you have some sort of extensions, but for most of the message brokers, service buses, like other tools, there is like no built-in plugins, but you can easily write them on your own. So we are just checking the endpoint, sending a message, and returning this 202 status code.
Yeah, and this looks like a very simple concept. However, from at this point, someone could ask that, all right, so we do have this asynchronous request. Mm-hmm. So we published the command that was eventually consumed by the microservice. We started processing this command, but as we saw like 5 minutes ago, even though the processing failed itself, we still have like 202, right? So they accepted.
Right.
So the question is how we can actually inform the user about the operation status, because looking from the from the end user's perspective, I would like to avoid the situation in which I have to, do the long polling and ask my API gateway, let's say every 2 seconds, whether I'm ready with my operation, whether this actually succeeded. So how we can actually manage this?
Yeah, and since it's a little bit complex topic, how we can manage this, I think that's good that we end this episode at that moment.
Yeah, once we discuss
the basic idea of API gateway and how we can, for example, make use of Ocelot and extend it with some custom, integrations with any type of infrastructure that you like. And then I think we can move to this async command processing, async request, because there is like a lot of things going on to make it work.
Actually, this small decision, like I want my API gateway to publish the messages asynchronously rather than doing the synchronous HTTP call, will imply a lot of infrastructural changes, and this will also require from us to actually understand some basic concept when it comes to the messaging within our distributed system. Yeah. So for this episode, this is pretty much it, and we'll move forward to the next section.